Hello, everyone. Welcome to another live episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today we're going to be talking about how to manage secrets in your applications using Azure Key Vault. And to do that, I am joined today by Tidjani.
Hi, Leslie. Thank you for having me.
Thanks for being here. So can you tell us a little bit more about yourself?
Yeah, definitely. First of all, well, thank you very much for having me. It's such a pleasure and honor to be here on the show with you. My name is Tidjani Belmansour. I'm a cloud architect at Cofomo, which is an IT consulting company based in Canada. I'm also a Microsoft Azure MVP for 3 years now. And I'm the co-host of the Azure Quebec community. You have the meetup link. Our community is free, and most of our events are virtual, so joining is free. So don't hesitate to be part of the community. We would love to have you on board. You can reach out to me on Twitter. You have my Twitter handle, Tidjani_B, and you have my blogs. So basically the same content. The first one is fastnuagic.com is my blog in French, and the dev2 is my blog in English.
Great. So secrets, what are they? Why are they so important? Why should we care?
Yeah, secrets by definition is that information that you don't want to share publicly. You want to restrict access to that information, right? Most of the time, we want to have control over this kind of information, whether it's passwords, whether it is API keys. You know, there are many kind of information that be critical or crucial to your business, your applications, and you want to have a clear vision, a clear control on who have access to this information. So this is what are secrets, and why we should care, because if we don't have a clear vision and a clear control on who have access to this information and what they are doing with this information, this can be harmful to our application and by extension to our business.
Cool. So this can range from anything to like passwords, as you mentioned, or SSH keys. Trying to think of other ones, like the key that you need to use an API sometimes, right?
Exactly. The example you just gave are the most common examples. Okay, but a secret can be defined depending on your industry, on your domain, on your application. So you don't have to be specifically limited to a set of passwords, encryption keys, and connection string, etc.
Great. So I'm sure you're going to share a little bit more about that and like how you can apply that to your own applications that you make, right? Because I'd imagine sometimes it can be kind of hard to have that right setup that's going to be secure for all of your users, as I'm sure a lot of people care about, right? Like, what are some of the challenges that usually come with trying to maintain secrets when you're writing an application?
Yeah, exactly. Usually, those secrets, you know, there is some understanding or some mindset around secret that it's hard to manage secrets, to secure access to secret information, and most of the time, security or securing this kind of information is not a single person or a single team responsibility, but it's a shared responsibility, right? So every person or every team in the organization has a role to play in order to make sure that this kind of information is kept secret, is not shared, and its use is not, it doesn't do harm to the organization or the business. Okay. So what we'll see today, we'll see at an elegant and secure way that will allow us to manage application secrets, and this regardless on the location of the application. What I mean by the location of the application is whether the application runs in the cloud or on-premise or on the local developer machine. We'll see at a unified way to manage those secrets.
Great.
Does that sound good?
Yep, that sounds good to me.
Perfect. So first, let's state the problem. Okay. There is a common understanding around managing secret. That is, managing secret is hard. Okay.
Yeah.
Yeah. I think we all have gone through this or one day or another. And essentially, and for convenience, we'll end up having some information in configuration files. And here you can see we have a tenant ID, client IDs, can be subscription IDs, we can have connection strings, and all of this information can be considered secrets, again, or sensitive information that should be secured, and access to this information should be restricted and controlled. Okay. What you see here for the tenant ID and the client ID are just random GUID. Okay, so
don't go trying those.
There is no secret to be shared.
Oh. That's actually the whole purpose of this talk. Here are some very famous secrets that you can apply to all of your popular extensions and applications.
Exactly. And usually in the connection string to, for example, SQL Server databases, we can see that we have the user ID and the password of the SQL login that's hard-coded in the or exposed in the application configuration file. So this is for convenience usually. Okay, it's not because we as a developers we don't care, security is not important to us, but it's for a lack of an easy and convenient way. Okay, and this is totally understandable because as a developer, our primary role and primary consideration is to develop features and application that will serve our end user. Our role or our core mission is to provide value to our users. So we used to think that security or managing secrets is hard, but it doesn't have to be. Okay, there are many ways that we can think of in order to keep this kind of information secret. So we'll explore during this session a certain number of ways. Okay, the first one is excluding the configuration file from the source control. Okay. The second one is using a special file known as secret.json. Another way is to rely on environment variables. Fourth option is to use a Key Vault reference. And another way is to rely on Azure Service Authentication. Okay, so don't worry, we'll explore all of these options today and see the pros and cons of each option.
Cool. I didn't know secrets.json was a thing, for instance.
Yeah. We'll dive into it in a moment. Okay. Mm-hmm. So just to summarize the pros and cons of every option that we will explore today. For the first one is configuration files. It can be web config or app settings.json, etc. So the obvious pro is that this kind of files can be used to manage any environment, whether it's development, staging, production, and so on. The inconvenient is that usually the information on these files is not encrypted. and that is stored in source control. So the combination of these two factors can do harm, okay? Not that we don't trust our people or our teams, but imagine, for example, you store an API key or sorry, or a connection string with a credentials in your configuration file, and you publish this code on a public repo. Okay, so you can have someone that a malicious person that can use this information and do harm to your application, or by extent to your organization. Okay.
Yeah.
Another option, the secrets.json, has the pros to be development only. So you can keep your secrets only on your development machine. You can use it either on Visual Studio or .NET CLI. So on virtually any code editor that you will use, including Visual Studio Code, for example. And it also has the advantage of keeping secrets out of the source control. However, the inconvenience is that, which is also an advantage, is that it's development only. Okay, so you can't use this secret information on, for example, once you deploy the application, you have to find another way. So you have to manage at least 2 different ways of storing secrets. One for your development purposes, and one for your for production or staging environment. Another inconvenience is that just as with the configuration file, the information is not encrypted in the secrets.json file, although the name suggests that it's secret. And it's stored on the development machine, on your dev box, so it has to be maintained for each development machine. Okay. Another way is environment variables. So this one can be used on any environment and any platform. So whether you are running on Windows, Mac OS, or Linux, you can use environment variable, and you can keep secrets outside of the source control. However, you have to define this information or this environment variable for each server. So imagine you deploy your application on load balanced environment. So you have, for example, 2 or 3 servers which are load balanced. So you have to define your environment variable on any and each of these server. And if you have to change the value of your environment variables, you have to update it on all the servers. Also, you need to restart whether your session or your application in case you update the value of the environment variable. And environment variable also store information that it's not encrypted. Okay, so the first 3 options have a common inconvenience, which is that information is not encrypted. If you want information to be encrypted, you have 2 options. That you have a Key Vault reference, and you have Azure Service Authentication. So both have the advantage of encrypting the information. Both have the advantage of keeping the information away from the source control, and they also have the advantage of decoupling the management of the secrets from the management of the application itself. Okay. However, Key Vault reference has inconvenience. The first one is that it's Azure only, and an Azure only solution. What does it mean? It means that you cannot use Azure Key Vault reference on your dev machine for development purposes. Okay, and right now, not every Azure service can use Key Vault reference. We used to say a good friend of mine, and I used to say that the cloud is a moving target, and especially Azure. so, so what we are saying here today might not be true in 1 to 2 or 6 months from now.
We'll have to do a follow-up episode. 6 months. So,
exactly.
What does it work for now?
But as of today, not every Azure service can benefit from Key Vault reference. Okay. So let's dive into each and every option we listed earlier. So the first one is excluding the configuration file from the source control.
Definitely done this one before.
How do we do it? Okay, so assuming that our code is under Git source control, so you have to edit the .gitignore file and add the path to your configuration file to the into that .gitignore file. And you have to one extra step, which is removing your configuration file from your Git repo. Okay, and how do you do it? Is by running this command, git remove -- cached, and you specify the path to your configuration file. What do you need? Why do you need to do this? It's because simply by adding the path of to your configuration file into the gitignore file is not enough. It simply tells Git to ignore this file and not include it in the commits from now on. But what if this file has already been committed to your source control? So it will still be here, okay, with the possibly the secrets in it. So you have to issue the git remove command in order to get rid of it from your Git repo.
Yep. Which that sucks if you don't remember to do that.
Yeah. If you forget to do the second step, yeah. If your secret has not changed or the value of the secret has not evolved, so you might be in trouble.
Which I feel like is possible to happen if you're coding away at like 1 or 2 in the morning or something.
Yeah.
Minimal sleep.
I came across a sticker a few months ago, which said "Don't code tired." It's good. I think it's good piece of advice here.
Yeah. Exactly.
So how do we add the path to our configuration file? As you can see on the screen here, as you can see, it's a relative path. Okay, it's relative to the location of the gitignore file. Okay, and here we are excluding the app settings.json file. So this solution may work, okay, because we get rid of secrets from our our code and the configuration files, but it's not natural, right? It's not natural to exclude configuration file from source control. Why? Because usually it's this kind of file is here as the purpose of maintaining some kind of information that we want to configuration information that we want to be able to change and modify in order to change the behavior of our code. And usually these configuration files are not meant to store secrets or sensitive information. Why? Simply because they are clear text. Okay, they are not encrypted. There is no permission management around these files. So they are not the right place to store your secret and sensitive information. And if you exclude such file, well, it's likely that your team will want to include it again, simply because this file is not meant to store information, sensitive information. It has other purposes, and they will need it for those purposes. For example, you can specify the environment in which you are running, and you want to store such information in your configuration file. And if the file is included again, and for convenience, we start again to put a connection string and API keys into that file. Well, we have gone to the original issue, right?
Right.
So we'll have to figure out an easier or a more convenient way to store our secret. So the second step, or the second option we can think of, is to rely on a special file which called secrets.json. Okay, what's that file? Well, if you are running Visual Studio, it's a special file. If you right-click on your project in Visual Studio, you can see the option named Manage User Secrets. Okay, so if you click on this option, you will have a configuration file that is stored outside of the source control. So it's not committed to the source control, and it resides only on your development machine. Okay, and also it's not listed in your Visual Studio Solution Explorer. So can be some kind of magical file in which you can store your secrets, and you can be sure that no one else but you can have access to this information. Okay, so once you click on Manage User Secret, you can see you will have either an empty file if you haven't edited before, or if you have edited before, well, you will have the file displayed with the content you specify in it. Okay, but look at its location. It's stored in my user profile. Okay, it's not stored in my project, and also, as you can see here, it doesn't appear in my Solution Explorer. Okay, so now I can remove all sensitive information from my app settings.json file and put that information into this secret.json file, right? And I can still keep running my application just as I did before. So no code change, no configuration change. It simply automatically works. Okay. So how does Visual Studio know that it has to use this file?
I was going to ask, like, how does it work?
So if I go to my Visual Studio, okay, and I edit my project file, you see here, I have my user secrets ID, okay, and excuse me, I click on Manage User Secret. Okay, you see it starts with D03 and ends by FEC1. So let me try something else. Okay. You see, D03 and ends with FEC1 at the same point. Okay.
Cool. And is that just like a random GUID ID that you generated in this file, and then you name the folder?
Exactly. Okay. Exactly. So using this key, Visual Studio can know that we are using a secrets.json file, and the ID to find this file is this one, so it can access the file.
Cool.
Not so magic when you know.
Yeah.
Okay. So this file seems to be the perfect solution in order to keep the secrets away from the source code and from our source control, and keep those information secrets and private, right? But it has some drawbacks. The first one is that the file, it's at the same moment an advantage and an inconvenience. Okay, is that since the file resides on your development machine, you have to manage it yourself as a developer. And as you may probably know, probably in this situation too, we used to have multiple workstations. Okay, so for example, I have my workstation at home, I have my workstation at the office, and usually, yeah.
I think it exists. I don't know.
Let's say, as developer, we usually have at least 2 workstations, at least. Thus, if I have to work on the same project and I have to access those secrets, I have to keep 2 versions of this file, okay? One on each machine. And if the information on this secret information changes, I have to replicate this change on all the copies of my secrets.json file.
Right. So if you're like collaborating with people, this isn't ideal, right? You're gonna notify all your teammates, like, please update.
Exactly. And there's also a drawback, is that since it's still clear text, okay, so it's not so secret. Yeah, its access is restricted to only the development team or some particular people, okay, set of people, but it's still clear text and still not so secure. Okay. I'm not saying here that we shouldn't trust our people and not give them access to secret information, but I know that for me, having the least access access to sensitive information, the better. Okay.
Sure. And human error is always a thing too. So
yeah, exactly.
No matter how well intentioned.
Exactly. I don't like to have this pressure to make sure that I keep the sensitive information secret and private. If another team can manage it for me, and I can use it when I need it, that's perfectly fine for me.
Totally.
I won't feel offended not to have access to this information.
Yeah, like it's cool. Like I'm a Butterfingers anyway. You don't want me So I do have a couple questions from chat. First question is all of this applicable in VS Code? I think you mentioned this earlier.
Yeah, exactly. It's all applicable to VS Code. Yes.
Cool. So that includes like the future options that we're going to talk about soon as well. Cool.
Yeah, exactly. Yes.
And the second question, also from James, is why can't we encrypt the app settings.json file also?
Great question. When we in the past, when we used web.config file, there we had some tools in order to encrypt a sensitive part of this file. We could encrypt, for example, the connection string part, etc. But this happened. You need to issue a command in order to encrypt those particular section of the file. Okay, so it's not secure by default. That's the point. It's not that you cannot secure it; it's that it's not secure by default.
Cool. So you have to do some extra.
Exactly.
Yeah.
Exactly. And all the purpose is, as a developer, to avoid having to manage the security for this information. Okay. We want to be able to use it when we need it, but not managing the security around this sensitive information.
Cool. All right.
Okay. So now we are heading to option number 3, which is using environment variables. So environment variables allows us to decouple the management of the configuration from the management of the application and the code. It works on any platform. So whether you are on Windows, Linux, Mac OS, you have the same feature, which is environment variable. You can set environment variable, get environment variable, etc. And this information is stored on the machine, so not on the not in the source control. So we have different ways to use environment variable. I will at first I will talk about the way to manage environment variable inside of Visual Studio. Okay, and it works with Visual Studio Code too. So if you right-click on your project in Visual Studio and you select Properties, you will get to this the property window. You click on Debug, and then you will see the environment variable section. Okay, and by default, if you create an ASP.NET Core application, you will always have this environment variable by default. Okay, you can add environment variables by clicking on the Add button. Okay, let's see how it works actually. I like to have a screenshot in my slides, so if anything goes wrong.
Right? I do that too. Run into the issue before I didn't have screenshots, and then my demo crashed. I was like, oh, great. Okay, well, take my word for it. So yeah, I take screenshots for everything now.
Okay. So here, just as we saw on the slide, you go to Debug, and you can see here environment variable. So you click Add, and you can add a new environment variable. Okay, so let's say event. Okay, let's say here Toolbox, right?
Yep.
And now I have another environment variable. So what will happen? Well, in my project, Visual Studio project, there is a special file here called launch settings.json. And here we have multiple profiles, okay? And in each profile, we can see that we have a section where environment variables are stored, right?
Yep.
So if I go back to Visual Studio and open that file, launch settings.json, here you can see I have this environment variable that we just created. Okay.
Yep.
And as you can see, it is associated to the IIS Express profile and not to the VS Toolbox that manage secrets.web profile. Okay. Why? Simply because when I created, I selected this profile. Okay. So if I change the profile, I can have here another environment variable. Let's say host channel 9, for example. And now here we can have it. So we can have a different environment variable for different application profiles.
Great.
Does that make sense?
Mm-hmm.
Perfect.
So it's good that you can categorize in that way too.
Exactly. So if I'm running Visual Studio Code, for example, I can, or any code editor, I can use the .NET CLI to launch my application using a specific profile. Okay. Mm-hmm. So here I specify the name of the profile. You see here, it's VS Toolbox.managedSecret.web, and it will run the application based on this profile, and I will have access to these environment variables. Okay.
Great. Mm-hmm.
But here you can say, well, Tidjani, it's not really environment variable because they are in the code. Okay, still in configuration file. It's launch settings.json is some kind of configuration file, right?
Mhm.
So what the point? Why are you talking about environment variable? Well, here you are right because this environment variable are stored in the code, and you can see them as fallback environment variables. Okay, so if you didn't define environment variable in your machine, this environment variable that are stored in your launch settings will be used. Okay,
Cool.
so it's a fallback. It's not the real. It's not the. It shouldn't be the real value that you are running. Okay.
Gotcha.
So how do we define the real environment variables? Well, it depends whether we are on Windows, Linux, or Mac OS. We'll see the different options. If you are on Windows, you can go to the system settings and click on Advanced System Settings. And here you can click on Environment Variables, right? And you can define the environment variable. Does that make sense?
Yeah.
Perfect. But you can also do it either in the command line or PowerShell. So how do you do it? Simply by using the command name set and specifying the name of the environment variable or the key equal the value. Okay.
Great. What's that? Is that just different terminology?
Yeah, great question. Just before I answer your question, I show the PowerShell syntax. Okay, the PowerShell syntax is a little bit different from the set. Okay, although set will work too in PowerShell. Okay, so great question. What difference between set and set X? Well, set will define this environment variable for the current session of your terminal. So if you close your terminal or your console and go back, start a new console session or new terminal session, that environment variable will go away.
Oh, okay. So it's temporary.
Yeah, temporary, exactly.
If so that's pretty good for like if you're testing something out.
Exactly, that's right. Perfectly, perfect example, right? If you want to persist it across sessions, you use the setx command. Okay, what does it mean? It means that this environment variable will persist on for every terminal session in your user account. So if Leslie, you and I are working on the same machine, and you define this environment variable using the setx command, and I later log into the same machine with my user account, I won't be seeing that environment variable because it's specific to you, to your user account.
Yeah.
Does that make sense?
Yeah, it makes sense. So
Perfect.
this is good if you have the multiple machine set up, but same user profile, and you can.
Exactly. Okay. Exactly. So what if I want to make or define an environment variable machine-wide? Well, I will use the setx syntax and simply add the /m for machine at the end of the command. Okay. If I use PowerShell, the syntax is a little bit more verbose. It actually
PowerShell.
Yeah, exactly. Well, verbosity have some advantages. Okay, you can easily understand what's happening here. It's clear that I'm setting an environment variable.
It's like a method call.
Yeah, exactly. Well, the first parameter is the name of the environment variable. The second is the value. And the third one is the scope. So here the scope is the machine. Okay, so it's machine-wide.
Great. Are there other scopes, I'm guessing, aside from machine, that you can specify?
Yeah, it should be current user. I don't know them by heart, but it should be current user, etc.
Gotcha.
So what if I'm running on Linux and macOS, because .NET Core and .NET 5, 6, and so on have that advantage that I can use them on any platform.
Mm-hmm.
So I want to define environment variable on any platform. Well, you can use the export command, which works both on Linux and macOS. Same command as for Windows, just replace set or setx by export. Okay. So export will define the environment variable for your user account. Okay, and if you want to persist it for machine-wide, okay, you will have to write this command into a special file called dash profile.
Cool, interesting.
Okay.
So
Makes
that's
sense?
just an arbitrary file that you create called dash profile.
Sorry?
So is dash profile, that's just a file you can just create from manually? And
yeah, it should be already a part of the system.
Okay.
So now we defined the environment variable. And now how do we use them? How do we get this value from this environment variable? So in .NET, we have a special class which called environment. And we can call the method named get environment variable and pass the key to the environment variable as a parameter. And it will return the value. Okay. I'm just noticing that I like a parenthesis here.
Yeah, I'm fixing the post.
Okay, so this approach has the advantage of keeping managing the secrets and managing the code separate. Okay, and usually me as a developer, I will focus on the code, and there is an operation team that will focus on managing the environment variables and their values. Okay. But it still has some drawbacks. The first drawback to be mentioned here is that environment variables are configured and maintained on a per machine basis. So as we mentioned previously, if we have our application is deployed to a load balance environment, so we'll have to go to each server and configure or maintain this environment variable. What I mean by maintain is that if the value of the environment variable change, well, I have to replicate the change on every machine or every server. Another drawback, which is the most important for me, is that information is not encrypted. Okay, the value of environment variable is not encrypted. And if you change that value, you will need to restart either your session or your machine, depending on the scope of your environment variable, in order for the update to take place.
Yeah, that's not fun. Okay. No one likes to restart.
Not fun. Exactly.
Great. It looks like this is a popular thing for people to use. I'm seeing in the chat a couple people, or is one I saw. I thought it was very clever for storing my secrets in environment variables. And then somebody said,
environment variable, just not to be mistaken here. I'm not saying that environment variable is a bad approach. It's a great approach. Okay, why I like so much environment variable is that because it's a common or a unified way to define a configuration parameter, configuration variable, independent on the kind or on the kind of the application you are running. Okay, so if you rely on environment variable, your code can be either on .NET or JavaScript, Python, Go. All of these technologies know how to work with environment variables. Okay, it's not specific to a given technology, so it's a great solution. What I'm saying here is that it's not suitable for sensitive information.
Cool, makes sense. So I do have a couple questions in chat before we move on. The first one I think goes back to the secret.json file more specifically, but can we have multiple secret key files in one machine? So one secret file for each environment.
Yeah, you can have multiple secret file on the same machine, just you can't have multiple secret file for the same project.
Okay. So
each time if you have two projects on the same machine, two Visual Studio projects, you will probably have two secret.json file. Okay.
Gotcha. And the second question is, how do you manage secrets with a WinUI app? I think you're using a .NET Core app if I'm guessing your examples. So.
To be honest, I don't use WinUI so much, so I don't know how to answer this question.
No worries. And those are most of the questions for now. Somebody is writing an extension right now to hide your config values.
Great.
Inspired people.
Oh, that's great. I'm so happy. Thank you.
So it's now the time for Azure Cloud Land. And
let's go to the cloud. Just before that, well, just before that, up to now we saw multiple options, okay, for managing secrets. But what happens if we have secrets defined in many locations? Okay, because that can happen. Well, there is an order of precedence that will be applied in order to use the appropriate version of your secret. Okay, let's say you have the same secret. Let's give an example, a concrete example. You define your connection string. Let's say we consider the connection string to be that's sensitive information, but you define your connection string into your secret.json file and into your app settings.json file. Okay, which one will be picked by your application? Well, it's the one in the secret.json. Okay, so if you define a configuration value parameter in the command line, it will be the one that will be used. Okay, even if you have the same one in the secret.json. If it's not found in the command line, your code will try to find it in the secret.json file. If it cannot find it, it will go to the environment variable. If it cannot find it, it will go to the app settings.json file specific to your environment, okay, which app setting.staging.json, app setting.dev.json, etc. And if it cannot find it here, it will go to the app setting.json, the general app setting.json file.
Cool, that's good to know. I'm sure there are cases where, you're kind of playing around with all these different options, and for whatever reason, it's taking one environment variable over another one and just ignoring another one completely. So it's good to know the precedence chain, so you know where to go first.
Exactly. I think we all came across at one point in time to some weird issue where you have the value, but it's not the you have a parameter, but it's not the right value, and you're wondering why it's not the right value.
I did everything right. What's going on?
and you double check the value always in the same file, but,
Yep.
but you are not aware that it's just because
you go
of
on
this.
Stack Overflow, I'm like, my file looks exactly like that person's file. What's going on?
Exactly.
Oh.
When sometime in a .NET stack, and we have some convention like that, which is very cool because it abstract away things from us and give us a given framework on how things work. But when you don't know about it, it can be you can get a headache because you're looking for something that it's not explicitly written somewhere. It's a convention, not a coding.
Yep.
Okay, so now let's head to the cloud.
All right.
So option 4, we'll use a Key Vault reference, right? Well, in order to show this, I think I can do a demo instead of showing you slides. And if things go wrong, I can go back to my slides.
Screenshots are for.
Okay, so here I have a web app, okay? And what I will do, I will I have an app settings, okay? In the configuration section, app settings, I've added an app setting here, okay? And the value of this app settings, as you can see, it has a special syntax. Let me open a new window. Okay. Yeah.
And this is called Azure Key Vault, right?
Yeah, exactly. Is it large enough?
Spring?
Hmm? Is it large enough, or do you want me to?
Oh yeah, I think
to read
that's
it one side. Okay, great. So here, let's break down this syntax. Okay, we are calling a special method or special feature called Microsoft.KeyVault. Okay, and here we will pass a parameter which is a URI to a key vault. Okay, this URI specifies the URI to an instance of the Azure Key Vault, which is called demo key vault reference -kv, okay, which is my instance of the key vault. And I'm concerned about the secrets of that key vault, not the keys, not the certificate, but the secrets. And more specifically, the secret I'm concerned about is called super secret message.
great name.
Okay, great name, yeah. And here there is some kind of random GUID, okay? What is this? It's a specific version of that secret. Does that make sense?
Yeah.
Okay, so here, what I'm telling my app service is whenever you need to access the value of this application settings, go grab it from this key vault. Okay, I'm giving you the name of the instance of the key vault, the name of the secret, and even the version of the secret, right? And by specifying this this value, the app service here already knows that these app settings come from a key vault reference and not from a configuration. Okay.
All right.
So how does it get it from the key vault? So here in the key vault, I'm in the demo key vault reference -kv. I'm in the secret section, and you can see here I have my super secret message. If I click on it, you can see here I have multiple versions of the same secret. Okay, and you see here the one I'm looking for is starts with AC33 and ends with 8FDD. Okay, it's the one I'm mentioning here, right?
Right.
Okay, and if I click on this one, and they say show secret, okay, the value of the secret is that I don't want you to know. So you see here we have a green check mark. So that means that the communication between the app service and the key vault is successful. How we establish the communication between our app service and the key vault? First, I'm turning on the system assigned, or I can create a user assigned identity. So I have some kind of identity that will be running my app service instance, right?
Right.
If you turn on system assigned, it will create a managed identity that will have the same name as your web app. Okay, so here's VS Toolbox Managed Secret Web. Then I will go to the to my key vault, and here into access policies, and select the vault access policy permission model, and I will add a new access policy. Since I'm only using the secrets section, I will choose secret management, and here as you can see, I have multiple permissions on those secrets, but I'm only concerned about reading those secrets. So I will disable every option except the get and list. Okay. And when I say I do it, it will either your security team or your operation team that will do this for you. Okay, not development team.
Cool.
Okay? And here, as you can see, I can restrict access to the secret. Why? Because first I will only authorize this identity to have access to the key vault. And even if the identity has access to the key vault, I will restrict what this identity can do with the secret in the key vault. So it can only access the secret, and it only get the value or list the secrets in this key vault. Okay. So it cannot change the value, it cannot delete the secret, it cannot disable the secret. Now that I decided what permission I want to give, I will have to specify to whom I give this permission. And here I will give it to the identity of the application. Okay. And I will click on add to give this permission. I won't do it here because I've already done it here. Okay. It's here. And as you can see, I only give the get and the list permission. Does that make sense?
Yep.
Yeah. And that's why I have this green check mark. Okay. Now, if I browse to my application, I'm simply displaying the value of the secret, and you can see it here. Okay.
Very top secret.
Yeah, it's a It's a very cool demo, right? The one that you can use in production.
Yeah, of course. Recommend to everybody.
Yeah, I think everyone who's watching can impress their boss with this one.
Yep.
So just so you notice, if the permission is not established, you will see that red check mark. Okay.
Okay.
It will tell you that you have an issue with the permission here. Okay, so that. Okay, now if I run the application on my workstation, on my development machine, okay, localhost, you can see I have the syntax we saw earlier, okay, because Key Vault reference, unfortunately, at least right now, doesn't work outside of Azure. Since I'm running the application on my development machine, it's outside of Azure, so I can't use Key Vault reference right now. So, as great as this feature might seem, and if you are running on Azure, it's a wonderful option, option for securing your secret, but it's not. It can't be used everywhere. So it's an Azure-only solution. So you can use it for your development purpose, and you can't use it if you are running on-premise. And another drawback is that it's not yet supported by each and every Azure service.
Gotcha.
Yeah.
But, so before we get to option 5, I do have one question. Alexander says, it would be nice to get some guidance on how to do secret management with Blazor WebAssembly applications. So is there like a secrets.json equivalent or environmental variable format? Is that the same? That sort of thing.
Okay. Well, I think the solution will be option number 5.
Okay, cool. Can you give like or go through kind of quickly since we're a little short on time?
Oh, okay. Yeah. Sorry for that.
No worries.
Okay.
This is great.
Okay. So what's great about this last option is that it works independent of the kind of application. So either it's a ASP.NET Core MVC application, a Blazor WebAssembly, you can use it with every kind of application. Okay. And the purpose of this option is that it allows us to unify the way we access to Azure resources. So whether through our development workstation or whether the application is deployed on Azure or on premises or on another cloud, it's irrelevant on where the application is running. And it also avoids storing this sensitive information in a configuration file. Thus, with leveraging the Azure Service Authentication, we can do a better separation of the code from the infrastructure. So we don't need anymore to update our configuration file if the sensitive information changes. And we enforce and we have a better security because information is encrypted and it's not anymore stored in the source control. So it can not be used for an attack. So how do we do it? The solution is based on the use of the default Azure credential class that can be found in the Azure.identity library. And this class tries to authenticate using different credential providers, which are listed here, and in this order. So it will first try to get the information from the environment credential, then the managed entity, then the shared token cache, Visual Studio, Visual Studio Code, etc. Okay. Mm-hmm. So in order to make it work, we will need to add two NuGet packages in our application, namely the Azure.identity, which gives us access to the Azure default Azure credential class, and the Azure.security.keyvault.secret NuGet package. If you have used the Key Vault SDK previously, you may remember that the Key Vault SDK was in one NuGet package, and with the new iteration, Microsoft break down this package into different packages. Here we use the package which is specific to managing the secrets of the Key Vault. Why Microsoft chose to do this, which is to break down the packages into different packages. It's because if, for example, the key or the certificate management for the Key Vault evolves and new features are added to this, well, if you only use secrets in your application, you don't have to update your NuGet packages because you are not concerned about that evolution. Okay.
Mm-hmm.
I hope this makes sense. So now that we added these two NuGet packages into our application, we'll have to add a few lines of code. Okay. Here we specify the URI to the Key Vault. As you can see here, I've, for the sake of the demo, I've hard-coded the URI here. But I will pass that URI to an instance of the secret client. What's the secret client? It's a proxy class to communicate with the secret management of the Key Vault. And this class is coming from the Key Vault.secret NuGet package we've added previously. Okay, so I specify the URI to my Key Vault, which contains the secrets, and I'm passing here an instance of the default Azure credential class. Then I simply use this proxy class to go grab a secret. I'm passing the name here as a parameter. You remember we named our secret a super secret message, so I can pass here the super secret message. And here I can specify a specific version if I need it. Or there is another version of that method that only take the name of the secret. And if you do this, well, it will be the latest version of the secret that will be picked. Okay. Then you will have to do that value. I'm not misspelling it here. It's not an error. It's not a typo. It's really .value. Why is this? Just really quick here. Okay.
Mm-hmm.
If I go back to my secrets, and here's my secret. Okay, and I specify, for example, this version. The first value, the first dot value will bring you here. Okay, so you have the properties, etc. And the second dot value will bring you to the secret value. Okay, that's why we have two dot values. The second one should be named the dot secret value. It will be clear, but you know. Okay, so now I have the code in place, but I need to, or the operation or security team need to give my code access to this Key Vault. Okay. Mm-hmm. It's a little bit different from the Key Vault reference. We still have to go to access policy, but this time we have to pick the Azure Role-Based Access Control, or RBAC, permission model, and not the Vault access policy. Then we'll have to go to the access control and give my user and also the managed entity of the application that is of the managed entity that is running the application. Sorry, the Key Vault secret user role. Okay.
All right.
Now, both the application, the app service, and myself can have access to this secret. Now, if you run the application on Azure, it will have access to this secret. But for me, running the application on my developer machine, how can I access this information? Well, I will have to go to Tools, Options, go to Azure Service Authentication here, and select the appropriate account, which is the Azure Active Directory account under which my team or my security team gave me access to the Key Vault. Okay, just to make things clear. Okay, this have to match here.
Gotcha.
Okay, what's interesting here, and I'll do this really quick. No, not this. Here, as you can see, I can have multiple accounts. Okay, so if I'm working for different companies, I can pick the account that I need to use. Okay, for example, let's say I'm working for company one and they gave me access to the Key Vault on this account. I can pick this account. But tomorrow, if I'm working on another project for another company and they gave me access to the Key Vault, to another Key Vault on this account, well, I simply have to switch the account, and my Visual Studio now has access to secrets in the Key Vault. Does that make sense?
Yeah.
Okay, great. If you are using a Visual Studio Code, you don't have that UI. So how do you choose your account? Well, in Visual Studio Code, you have to install the Azure account extension and log into that extension with your account that has access to the Key Vault, and the magic will happen.
Gotcha. So the wider Azure extension, that's what you're referring to, right?
Exactly. So now I have access to this secret, but here I want to access my database based on my credential. Okay. So here I will grab the connection, the DB connection to my Azure SQL database, and use this command to get a token, okay, based on my identity. So the account I picked in my Visual Studio, it will issue a token request command to obtain a request to the database and pass that token as the access token to the database. Okay. So in order for this to work, our SQL server, Azure SQL database server, we have to enable Azure Active Directory and define an admin. Usually we'll have an Azure ID group, let's say DB admins, that will manage that database server. And these admins will have to log into the database and issue some grants on the database. So they will have to create a user first and specify from external provider. What does it mean? That means we'll create a user here, but this user comes from Azure Active Directory. Okay. And then this user will give him a select permission. We can do the same for the managed entity of our application. Okay, so here, once again, we have a granular access or permission. So my user only can do select on the database and can do no harm to the database.
Great.
Okay, and then here I can access the database as usual. If my user don't have permission on the database, it will have we will get a SQL exception, and the message will be login failed for user token identified principal. So we'll know that our user don't have permission on the database. So in summary, this solution we just saw is an elegant and secure way to manage secrets, because it decouples the management of the secret from the usage of the secret. It's easy to set up. Why? Because as developer, I only have to select the user account who has access to the secret and use the secret. The security team has to manage access to the key vault and manage the values of the secrets. And the database team has to manage permission on the database based on this on the Azure AD identities. Okay, and the beauty is that it has no impact on the application if something changes. So if we change the permissions or we change the value of the secrets, the application code doesn't have to change.
Yep, that's great. Having that space between your application code and the actual secret stuff.
Exactly. It's a separation of concerns. Well, thank you very much once again for this wonderful opportunity. I hope it was valuable for the people watching this session.
Yeah, that was really great. I learned a lot about secrets. I didn't realize there were so many options to begin with. Like I was familiar with just like the basic app settings, JSON, and was not familiar with secrets.json, and environmental variables I was. But yeah, it's cool that there's so many different options for different scenarios, both convenient and just more advanced, and actually getting that encryption and things that you want.
Well, I'm so happy I taught you something, because I thought I learned so much from you. I see it as a giving back.
Awesome. Well, I appreciate that. So I guess we're even.
Not yet. I learned much more from you than you learned from me. So.
Well, thank you so much. And yeah, thanks for coming on the show and sharing about secrets. So because we're short on time, be sure to check out Tidjani's Twitter and his blog post. I have a banner for it somewhere. Oh, that's your blog, right? That one?
Perfect.
Great. Yep. Go check that out. If you have any additional questions, definitely go reach out to him. He's really cool. And yeah, thank you so much for being here yet again. And
thank you for having me, Leslie. That was a great pleasure.
Hope to have you back in the future. So,
I would love to.
Yeah, absolutely. Love to have you back. So go try out your new secret techniques, y'all. And until next time, happy coding.